everybody, welcome back. Today is our final full day of e-learning. Obviously Friday will be a day for you to ask a lot of questions. There might be an additional e-slip to kind of give me the final bit of feedback I need going into break. So hopefully all is going well for you. What we have today is an extension of our hyperbolas. This first example is actually one we could have done yesterday. There's nothing special to it. So I'll do it real quickly, just kind of as another sample problem in case you need some clarification. But primarily when we get to examples 2, 3, and 4, each of them are the new focus for our second day of hyperbolas. So with hyperbolas, I want to just remind you that this lead term being an x squared tells us the name. And so this particular box doesn't have room for the name, but we know that we have seen that in yesterday's homework, so I'm just going to go ahead and write it here at the top. And since the x squared is first, that means it will be a horizontal hyperbola. Now the other thing that we notice is that we have an x squared prior to the y squared, but I don't see any shifts on those. So that'll tell me pretty quickly that my center is at 0, 0. Now the radius doesn't apply, so I leave it blank because that's only used for circles. And I want to remember that with a hyperbola, the vertices will be listed and the co-vertices will not. And again, I'm going to try and spread those vertices, one on the first blank and one on the second. I'm not going to use this information for vertex, directrix, and focus yet. That'll be used when we return and we learn about parabolas. So as we look to vertices, we want to remember that in a hyperbola, the a squared is always first. So if a squared is 25, then that's going to give us an a value of plus or minus 5. And that's going to leave my b squared to be 36, and b will be plus or minus 6. So that is different from an ellipse, just as a reminder, because the rules are changing for the different shapes. So we do need to come up with our focal relationships, so I'll switch colors here just to kind of keep that easy to spot. And so c squared is going to be a squared plus b squared. And the reason it's a plus is because this equation is a minus. Well, that's not really the reason, but that's kind of the connection and the way to remember it. And so we're going to add our 25, which was already squared, right? And our 36 was already squared, so we didn't need to represent that differently. And we can get our c value to be plus or minus the square root of 61. Alright, so now I think I'm pretty close to being ready to graph. So what I'm going to do is draw my axes. Now I noticed that some of you are not drawing your axes, for those of you that have submitted your Hyperbola Day 1 homework. And so you're going to want to make sure that you draw those axes. I need to be able to see them. So I'm going to use purple for that right now. And because these numbers of 5 and 6 are relatively small, I can kind of put the axes wherever I'd like because I think things will fit. If the numbers were larger, I might have to be careful and, perhaps off-center my axes a little bit to make sure things are working. As you can see, I didn't put this directly in the middle, but that's okay as long as these numbers that I need will fit on there. So from the center, I want to count 5, but 5 in what direction? So I just want to remind myself that that comes from the x, and so that's going to be left and right 5 from the center. And remember that this center is still at 0, 0. The future examples for today will not be that location. So then when I look at the b, I'm going to switch to a different color, and I'm going to count 6 in a y direction since it's underneath the y. And I'm going to remember that I'd like that to be an open circle because it's not a point on the graph. Now I do want to see that guide box. Again, I know some of you are using a pencil, and so maybe the technology of taking the picture is making it hard for me to see, but please try to make sure that I can at least see that guide box, because for some of you, I don't feel like you're actually graphing it well. So one of the things I noticed is that sometimes the distance to the left of the center and to the right of the center doesn't appear to be balanced in your graphs, or above and below the center, wherever that center is. And that worries me. Plus, when you're graphing the asymptote, I'm going to show you what I don't want you to do. Many of you are graphing the asymptote directly from just the diagonal, and then you stop. And that's not what we want to do. We want to extend that line quite a bit so that it fills our graphing space. And we want to do that for both asymptotes. And the reason we want to do that, again, this is identical to yesterday for those who watched all the videos, but it's not really what I'm seeing you put into practice, so I feel like it's worth emphasizing again. And that is that when you are getting ready to draw the actual hyperbola itself, we want to make sure, since it's a horizontal hyperbola, that we use this vertex of, for example, negative 5, 0, and 5, 0, that we start there, but then we want to hug the asymptote, which is hard to do if that asymptote hasn't been extended. If it only stops right here, then you're often giving me a branch that really isn't being graphed where the hyperbola would go. So it really needs to kind of come towards that asymptote quickly and stay as guided by the asymptote. So again, we're going to connect to the vertex and make sure that it hugs the asymptote and that it hugs the asymptote. So our vertices are listed, the covertices are not, so now we need our foci. We also want to pay attention to whether the foci affects the x or the y. Well, the foci will affect the same letter as your vertex, and so your vertices went with the x, which means your foci values will be negative root 61, comma 0, and positive root 61, comma 0. Make sure they look like ordered pairs. And again, spread them out so that they're a little bit easier to read, especially when you're taking a picture and sending me the work. All right, last thing that we have left to finish for asymptotes are, for our hyperbola, are the asymptotes. So we want to, if we need to, we can certainly kind of write the point slope form. Y minus y1 equals the slope times x minus x1. That's the way you've seen me do it in all the examples. It just seems to me a more familiar formula than switching with a and b and some things of that nature. So I want to make sure that I put my center in there, and then that I remember that there are 2 of them. And I want to do the vertical, so I want to count vertically, that's 6, and the run is 5. Now, one thing that I noticed some people doing is they weren't simplifying this to the simplest direction it can be. Since these are zeros, there's no reason to leave those in the answer, guys. And I will say, I like to write it compactly into plus or minus 6 over 5 x. Some of you are choosing to write this separately as 2 distinct lines. I'm very comfortable with that and actually feel pretty good about that because it's emphasizing to you that there are 2 different lines. And there's example 1.